Good evening, this is Kavipriya, Assistant Professor, AC Department. I am going to deliver about the topic comparison of various pulse communication technique. So it's a comparison between PAM, PWM and PPM. So first, what is this PAM? PAM is a pulse amplitude modulation. It's a process of varying the amplitude of pulses in proportion to the instantaneous value of the message signal. So the pulse amplitude modulation is used in the first. It is the first popular Ethernet communication standard. So the diagram, first one is a carrier signal and second is a message signal and third is a pulse amplitude modulated signal. And next is a pulse width. Here the width of the pulses is varied in proportion to the instantaneous value of the message signal. So the width of the pulses varies but the amplitude of the pulses remains constant. Amplitude limiters are used to make the amplitude constant. In pulse position modulation, the position of the pulses is varied in proportion to the instantaneous value of the message signal. Pulse position modulation is done in accordance with the pulse width modulating signal. Each trailing of the pulses with modulated signal becomes the starting point for pulses in the PPM signal. So we are going to see what is the difference between this PAM, PPM and PWM. Okay, first thing is that the type of carrier in case of the PAM is a train of pulses. It is same for pulse width modulation and also it is same for the pulse position modulation. And here second one is the variable characteristics of the pulses, nothing but for PAM it is the amplitude and for PWM it is a width, and third one is for pulse position, it is a position of the pulses. So the amplitude of pulses is varied in PAM, amplitude of the width of the pulses is varied in case of the PWM, and position of the pulses is varied in case of the PPM. Bandwidth requirement for this PAM is low, for PWM and PPM it is high. Noise immunity in case of this PAM is low. It is less immune to noise, whereas PWM and PPM it is highly immune to the noise. And the information contained, it is based on the amplitude variation, and for PWM it is a width variation and for PPM it is a position variation. Power efficiency, or it is a signal to noise ratio, is very low in case of the PAM because it is less immune to noise. So the signal to noise ratio, it is nothing but ratio of signal strength to noise, it is a very low since the signal quality is very low. And in case of PWM it is moderate, whereas in case of PPM the signal to noise ratio is very high, so it is highly immune to noise, so the quality of signal is very high, so the SNR is very high. And transmitted power is varies with the amplitude of pulses in PAM, it varies with the width of the pulses in PWM, and whereas in case of PPM it is remains constant. And next is a need to transmit the synchronizing pulses is not required in case of the PAM, whereas in case also PPM also it is not required, whereas in case of PWM it is necessary. And the bandwidth requirement depends on the width of the pulses, it depends on the rise time of pulses, and also the bandwidth depends upon the rise time of pulses for PWM also. And transmitted power in case of PAM is instantaneous transmitted power, it varies with the amplitude of the pulses. Whereas case of the PWM, it is instantaneous transmitted power varies with the amplitude and width of the pulses. In case of PPM, instantaneous transmitted power remains constant with the width of the pulses. And complexity and of generation and reduction is complex in case of the PAM. In case of the PPM also it is complex, whereas PWM it is easier. And similarity with other modulation technique, this PAM it's similar to that of the amplitude modulation, and this PWM is similar to that of the frequency modulation, and PPM is similar to that of the pulse modulation. And the key difference between PAM, PW and PPM is that the factor that generates a key difference between this PAM, PWM and PPM is that PAM amplitude of pulses shows proportionality with the amplitude of the modulating signal. In PWM, width of the pulses shows a proportionality with the amplitude of the message signal. In case of PPM, position of the pulses shows a proportionality to the amplitude of the analog modulated signal. PAM technique shows low immunity towards noise, as against PWM and PPM have a low noise interference factor because a noise immunity is very high. In PAM and PWM techniques, transmitter and receiver synchronization is not required, but PPM technique is need that requires a synchronization between the transmitter and the receiver station. In SNR in case of is low in case of PAM, whereas it is moderate in case of PWM and high in case of the PPM. Transmitted power in case of PAM and PWM is variable due to variation in the amplitude and the width respectively. However, it is constant in case of PPM because both amplitude and width are constant in case of the PPM. In PAM, transmission channel bandwidth relies on the pulse width. In case of PWM and PPM, rise time of pulse is a factor on which transmitter channel bandwidth depends, as the position of pulses is changed in PPM. Therefore, it requires a synchronization pulses, while both BAM and PWM does not require synchronization pulses. In all, PAM, PW and PPM show similarity in the implementation with the AM, FM and PM. So, PAM shows a similarity as that of AM and PWM shows the similarity as that of the FM and PPM shows a similarity as that of the PM. The bandwidth requirement is low in case of PAM, but it is comparatively high in case of the PWM and PPM. So that's all about the comparison between the PAM, PPM and PWM, which are the pulse modulation techniques. And also we have seen what are all the key requirements required for this PAM, PPM and PWM. Thank you.